Good morning, and we'll be prompt because we don't want to keep anyone longer than the hour we have slated. So good morning, gentlemen. My name is Patrice Kelty, and I'm going to introduce Mark Bannayan, who's VP of Sales for Grinding Technologies, and Joe Denny, who is, Joe, I apologize, your title is?
Engineering Manager for Glebar.
Engineering Manager for Glebar. All right. Mark and Joe, Mark, why don't you introduce yourself quickly, give a little background, and then Joe, and then we'll move on with the presentation.
So Mark Bannayan, VP of Grinding for sales at Glebar. Been with Glebar for about a couple of decades. So I have a long history with the offerings we have, especially on the Guidewire and medical component side of the business.
I'm Joe Denny. I rose up through the ranks of engineering here at Glebar. My background is mechanical and controls.
Excellent. So David, there we are. And then Mark, if you'll just take over.
Sure.
We'll have the history of Guidewire grinding.
Yeah, so we're going to go over the history of Guidewire grinding and how Glebar's involvement was since the 60s. Also going to go over the different technologies we have for this application and discuss scaling efficiencies through automation that we offer. And at the end, we'll open it for questions and answers from our audience. So our involvement in the Guidewire industry started back in the 60s. Traditionally, Guidewires were made using chemical etching process, which is a pretty toxic process, very time consuming, and also doesn't have the accuracy that's needed. And over the decades, the requirements from the Guidewire industry were such that you needed to have better accuracy, better throughput, easier setup. So over the years, in 1966, we started grinding single taper guide wires. As the guide wires got more advanced, requiring multiple tapers, the technology at the time was not available to do multiple taper guide wire. So we developed a patented system using sensors at the time. This was back in '89. And that gave us the ability to grind multiple tapers in one process. So that was a revolutionary idea. And since then, we also developed a different way of handling guide wires, in the sense that traditionally they were done in centerless, which is a fast process, but at the same time, your length tolerances are much wider. So the requirement for tighter length tolerances made us rethink the way guide wire processing should go forward. So we developed a process of an OD grinding system called the CAM process. Now we do still provide centerless for certain types of wires that require speed but have less accuracy requirements. And on the CAM side was much tighter tolerances and the ability to grind flats and threads in different shapes. So that was developed in 2000. By 2008, we also had a lot of automation integrated into the CAM system to include other processes like cutting to length, extracting shorter parts, also integrating sandblasting processes, multiple steps that were done post grinding. We integrated within the grinding envelope to shorten, to minimize the material handling from the operator perspective. We also developed gauging systems to measure these wires, because as the wires got more and more accurate, more requirements for tighter tolerances, the traditional way of measuring them became more and more obsolete and more time consuming. So we developed the P4K system which is the fastest and is in the industry standard for measuring guide wires. So that system measures at 4,000 scans per second and provides a lot of data that can be stored in a network. You can do CPK analysis and all kinds of different, which Joe will go over as we go forward. The other breakthroughs we've made in this industry as well is handling, feeding, cutting, and basically automating the whole grinding process for guide wires. So we developed various types of feeders, off spools, or extractor with programmable capability where you can move the grind section from one to the next at a very fast pace. And we'll go over that in a few seconds. Next slide. So these are some of the capabilities that we do. As you can see, there's helical threads. There's some flats. We can go down to under 1,000th diameter on the CAM machine, all in one operation. And on the centralist portion of our business, we can do traditional multi-tapered guide wires, paddle grinds, and parabolic grinds. So the challenges that we see our customers face on a daily basis is on the material side. There are different materials coming into play with guide wires, whether you're dealing with SLT, different grades, nitinol, super elastic nitinol, different types of alloys. They all react differently through the grinding process. So what Glebar does, we have multiple hundreds of grades of wheels that we test these different materials so we can achieve certain surface finishes. Also, tighter tolerances are becoming more and more required. So that's what we've built into the equipment to be able to meet those challenges. The other thing we see is a skills gap in the field. Going back 15 years, 10 years ago, there was we had a lot of skill in the industry where people could basically set up a machine and make it grind wire down to 0.002 of an inch. That skill set is retiring, moving on. And we've recognized that challenge. So we've replaced that with the control side. So the controls aspect of our machines address the lack of skill in the marketplace. So we built the system so you could train somebody and get the machines up and running within a week. And when one person could run 5-6 machines in tandem. Cycle times, of course, everybody's under pressure for faster cycle times. And that's what we work on here in R&D on a daily basis. And it's also, we've developed under MMT, we're 10 different companies. So we have a huge infrastructure of service and support for our customers to make sure they're trained properly, that they have the parts they need to keep the machines up and running. And also that we are there to support them with new product development as far as new guide wires that they want to develop. So take it to Joe here, who's going to go over a couple of case studies that we've done on all the systems that we have.
So Mark mentioned a lot of challenges that obviously you're here, so you understand most of them. And I'm going to walk through them and help us understand how we're solving them. So for everyone here, we're familiar with the stainless, the SLT, the nickel titanium alloys. They're kind of a pain. They're difficult materials to work with, and when we're presented them, we're starting out with material that's at around 30,000ths of an inch and only getting smaller. So controlling the stock and actually maintaining position of that stock is a challenge. We've approached that challenge in two different ways. On the CAM.2 system, we have our patented dual collet system, which allows us to grab and fully orient and align the parts throughout the grind. That, coupled with our additional captivation and tooling, allows us to have total control of length, orientation, allowing us to stop the wire, spin the wire, pull it back, push it forward, make the wire do whatever we needed to do during the grinding process. That, coupled with whatever wheel selection for the appropriate tooling, additional coolant delivery options, allow us to have full and finite control over that wire. Going in the other direction on the GT9AC wire, we are running a true centerless system here. So it is actually the grinding pressure that is pulling the wire through the grinder. Thus, we, with the proper captivation, we then have the wire running in full tension the entire time, and we are tracking the tail of the wire using a camera system, which I'll get into a little bit more later. That gives us full knowledge of where the wire is at all times during the grind, and allowing us to have full linear accuracy during the grind. So this is the dual collet system in motion. You can see the wire is everything is positioned in the grinding cell to prevent buckling and keep the wire fully in line. David, can you take us to the AC? And once again, fully captivating the wire in the grinding system of the GT9AC, pulling it through with centerless grinding. And we'll focus on the camera aspect a little later. David, if you could pull us forward. So the envelope is always being pushed with tolerances. So both machines are built on a granite bed for stability. It's the same granite that you're going to use for all of your inspection equipment. So that helps us with both stability and vibration dampening in the system. All of our controls are centered around servo systems with 0.1 micron linear scales. So on the CAM system, when we actually go in and do the grind, the front of the wire is located with a fiber optic sensor, and then the dual collet system grabs the wire and never lets go. It is a hand-over-hand feeding, so at no point during the cycle is the wire ever unmanaged. I know there are some other systems where you will have a hitching sequence where you could go for 12 or 18 inches and then you're going to have to hitch, and that first 18 inches will be good and the second 18 inches will be good, but you don't really know about one to the other. But with the true continuous holding of the dual collet system, there is no point. The 30 inches down the line will be just as accurate as the first 5. And then on the GT9AC, we use the same fiber sensors to find the front of the wire, and then the camera system finds the tail end of the wire. And now we know the length of the wire. So we know relative to the tail end of the wire where the front of the wire is at all times. That means that as the wire is pulled through the grinder by the regulating wheel, we know where we are. The camera it is not a canned sequence, it is a dynamic sequence. So as you change the reg wheel speed during the grind and approach different diameters on the guide wire, your speed is going to change during the grind, and you can push certain sections of the grind faster and slow down certain sections for accuracy, but the camera will react and you will know where you are, and the servo systems will then react to put the appropriate profiles into the wire. And both machines then take full P4K feedback, which we'll get into a little bit later. There we are. This is the GT9AC feeder, and you should be able to see a little blue light. That is the camera system tracking the wire. There we are. So the entire time that you're grinding, the machine knows exactly where your wire is. And then on the CAM system, and this graphic is going to be applicable to the 9AC as well. Since the machine knows perfectly where it is going to display that on the screen for the operator so they don't have to guess. They can just watch the machine run, and it is full real-time feedback for the operator. Which leads us nicely into our skills gap with the operators. We all know that the entire workforce is facing a skills gap, and we were always in a unique field of medical manufacturing. So what we've done is we've focused on taking the intelligence and putting it into the machine. So everything is touchscreen and everything is conversational. So the machine is running G-code. Operator doesn't know that. Operator doesn't need to know how to write G-code. The operator, all of the actual programming aspects are digested into a conversational language that they can read straight off of the Guidewire print and put into the system. And then all of the features for the different accessories, whether you're running in our OD or our centerless mode, whether you're using an extractor or a spool feeder or a wire cutter, they are all saved in the process on the machine. With our infinite part library, you can pull up a part that you ran 3 years ago and it's still there with all of the features, everything saved. With our system, we've found that we can traditionally train an operator to run our machine within 3 to 5 days. And with that training, they can then and all of the intelligence built into the machine, they can then reasonably be expected to run multiple machines. And with all of the accessories that are incorporating multiple operations, the cycle times are made possible that they can be monitoring all of them without much effort. David? Which brings us to improving all of our cycle times to meet our higher demands. Envelope is always being pushed once again for cycle time and throughput, and both machines are designed to accomplish what would have been several slower processes. So from taking the material off of a spool and cutting it to length, that's integrated into the machine. The grind that would have previously have been several different operations, all included in one operation, one program. Any post-processing, such as sandblasting that's necessary, that can be done on the machine. And then removal, final cutting, and extraction from the machine, all can be done on the machine, removing steps of human interaction, removing opportunities to damage the wire mid-process. And then all of the machines have P4K feedback. The P4K is the profile measurement system that measures the entire length of the wire, grabs length and diameter positions, gives operators clear go and no go, and then all of that data can be pushed back to the machine to adjust and correct anything. David, I believe you have a little video. So this is an extractor on the GT9AC. These wires were starting out with a 13-foot wire. We are grinding one end of the wire, pushing it through, grinding the other end of the wire, cutting it off, and getting multiple parts per wire in what would have traditionally been a 2 setup, already cut to length grind. Okay. All right. And there will always be the challenge. They are machines. They will need maintenance. They will routine and unforeseen. And that's where our larger team comes in. Through MMT, we have been continually growing our team of skilled technicians around the world. We just implemented a series of technicians in Ireland to extend our European presence. All of the machines are set up for remote troubleshooting, so we could dial in at any time of day and help you get back up and running if it's a minor issue, or if it's a major issue, or if you just want to have our team come in and do all of your pre-planned routine maintenance. Our techs will always have their toolboxes packed and be ready to get on site for you at a moment's notice. So looping back around, the CAM2 is a full-featured Guidewire production line condensed into a small package. The dual collet system provides for unrivaled precision as we move the part through the grinding process, and then using the P4K for gauging and any of the other accessories, it provides unrivaled versatility and whole process capability. David, are you able to start that video? Walking through a few of the features that we pride ourselves with. This machine is equipped with the spool feeder, so it will unspool and cut to length as it grinds. And the wire is fully captivated and pushed into the machine, where the dual collet system takes hold of it. And then it can be ground to shape. And then in this process, we're doing cutoff and extraction of short wires. So for this specific application, we're taking 16-foot wire, or we're taking a spool, creating 16-foot wires, and then cutting that down into 2 or 3 inch long parts, producing 1 part every couple of seconds. And then moving on to the GT9AC. So the GT9AC brings back the unrivaled speed of a centerless grinder and couples it with high-speed precision and controls, allowing for high throughput and tight tolerances. And I know it is a centerless grinder, which to some can be scary, but we've integrated features such as automatic blade sizing and touch off, and among other features to help make some of the more mystifying processes easier for operators and repeatable for today's operators. David, I believe you have a video as well. So these are just a few of your standard parts that are going to be run on the GT9AC. So the wire will be fed in. This machine is also capable of having a spool cutter or an off-the-spool system. And then the camera, which is that blue light, will find the end of the wire, measure the wire, and then track it through the grind, moving the regulating wheel away as necessary to create the desired shape. All right. So, and then there's the P4K, which has become the industry standard for guide wire measurement. It scans the entire length of the wire, capturing its profile and calculating all of the gauge points for a quick and easy go, no go response. And then all of that data can then be fed back to the CAM and the GT9AC in order to make size compensations on various features or the whole wire. And everything is set up for the network. So all of the scans and data is saved, recorded, and made available for CPK and any other statistical analyses that you want to make. And because everything can be on the network, it can all be in one central database, where if you're running a lot among multiple machines and scanning it on multiple P4Ks, that can all be saved into one central database, eliminating any bottlenecks that might arise from high production volumes. You can see him scanning the wire. It's previewing the wire for you. Then it will run all of its calculations and tell you how well you made the wire and suggest any corrections. Now, not every wire needs the full features. Not every wire is going to be 13 feet long and have 15 different features. Sometimes all you need to do is deburr the wire, take that hard edge off, and that's where the GSR comes in. So it is a tabletop system that takes it, you present it a bundle of wires, it removes the wire from the bundle, it presents it into a dry grinding situation, so you don't have to worry about having an entire coolant system dedicated to this machine or cleaning the wire after. So after the deburring process, it is then presented to a camera, which inspects to make sure that the desired shape was achieved, and then automatically bins it into a good, bad, pass or fail. It's a quick and easy system, which helps eliminate operator strain, as it is a very repetitive process, and a fleet of these will outperform a fleet of operators. So that's a very quick and efficient process for deburring wires. So across the entire fleet of our machines, you can see how we've been addressing the industrial need for automation, handling all these different materials and form factors that guide wires have taken on over the years, and leading it into a method that has less material handling by an operator. So a fully kitted out machine will take the wire, cut it to length, move it into the grinder, do any post-processing and extract it. And all of this allows your shop floor to move efficiently, have one operator running multiple machines and producing high quality product. Just a few more glamour shots of the automation. All of these different options can be combined together in many ways in order to achieve the optimal process. I'm going to hand it back over to Mark.
Thanks, Joe. So we'll open with questions if there are any from the audience.
There is one question here. Which technology allows us to grind various sizes?
Say that again?
Which technology allows us to grind various sizes?
Well, it depends. I mean, you're dealing with our range of sizes on this equipment comes from thousandths of an inch up to 1/8 of an inch. For larger materials, we have different types of machines that can handle that type of grinding.
What about along the same wire?
Yeah, along the same, but basically the grinder will, the program will dictate to the machine what sizes need to be achieved. So with the controls aspect and the material handling side of it, you could pretty much generate any shape you want or any size.
Great. We actually have another question here. The data that is captured for length ODs during grinding, can that be exported to Excel later on? And what about any other programs that it can be exported to?
The answer is yes. Go ahead,
Yes.
Joe.
The answer is yes. So all of the data is available for export either as a CSV, Excel file, or printed out, or if you're using the online versions, it will all be saved into your network's SQL database.
Great. Thanks, Mark and Joe. I think we have a couple more questions coming in. I see the chat is lighting up here. I guess you guys did a great job presenting. How are the machines linked to one another for increased efficiency?
I'm unclear on the question.
Yeah, on the efficiency side, I mean, the machine is pulling data for every interaction with the operator, your throughput rates. So all the Industry 4.0 data is stored in each machine, and that's network compatible. So on the other side, you have the gauging side of the cell. One P4K can feed back to up to 4 machines. So I don't know if that answers your question.
The feedback is all done over the local network.
And can the production output be seen live when we export it into, as you said, across the network? Can you see the results as you see it the same on the screen through an internal network?
So if you are running a local terminal on one of your, not on one of the machines, if you're running a local terminal on one of your production computers, you will be able to pull up all of the same database. So all connections to the network will be pulling up the same database, yes.
You can determine what data you want to monitor. So your number of cycles, any size adjustments, all this data is stored in the system and can be extracted through a network.
I was answering specific to the P4K network. All of the OEE data is available on the machine and can be output in a series of forms such as MT Connect, SQL, OPC, all of the industry standard. So if you're running on your shop something like Predator in your shop, we can connect to that and give you all of your data.
Can you monitor the number of parts per minute or per hour and see all the same information on the HMI on these local terminals to see it live as the machine goes? I think that's what you were explaining as well.
Right. So on the P4K, all of the data, if you're working on the network, the SQL version of the P4K, that's all live to the network and can be pulled up on any of the terminals. For the CAM and the AC, if all data can be exported live to any of your standard industry monitoring, such as Predator.
Great, thank you. I'm just going to pause for a moment to see if there's any more questions. I think that's all. Patrice,
And if
did
there
you?
are any questions that come along that you can think of, just shoot us an email at sales@mmt-inc. So we have a question. Do we have a sales rep in Costa Rica?
We have a technical service rep in Costa Rica, and he also handles some sales, but we're dealing with, as far as sales for Costa Rica is dealt directly with Ramsey, our Ramsey facility.
But we do have a service technician that lives in Costa Rica.
Yes. And yeah.
And we will send a link with a brief survey after this presentation. So if you'll have access to the recorded version. If you have any questions, please let us know. We thank you so much. Thank you, Mark. And oh my goodness, I don't know what it is, Joe. Today I'm just blind. Mark and Joe for helping out and sharing your expertise with the audience. Again, if there's any more questions, please let us know, and we're happy to engage with you later. And we'll give you all back 5 minutes of your day. Thanks so much, and have a great day.